This is a solution to problem number 1 from semester 2, review number 7. In here we're given one imaginary root or one complex root of a polynomial function, which is third degree, and we're asked to find the real root. So if you remember back to our unit on polynomial functions, if 2 plus 3i is a root or 0, then 2 minus 3i is also a root. And we can use each of these roots, the idea that each of these roots gives us a factor of the form x minus that 0 or that root. So we're going to have x minus 2 minus 3i and x minus 2 plus 3i. Those are going to be factors of this polynomial function. I'm going to go ahead and expand this. I'm going to distribute the negative, so I'm going to have x minus 2 plus 3i and distribute the negative in the second factor, so x minus 2 minus 3i. And then I'm going to group the x minus 2's so that it's a little easier to multiply this out. We recognize this as a difference of squares pattern, so this will become x minus 2 squared minus the quantity 3i squared. X minus 2 squared is x squared minus 4x plus 4. And then 3i squared is 9i squared. Remember that I squared is equal to negative 1, so this becomes x squared minus 4x plus 4 minus 9 times negative 1, which will become a plus 9. So x squared minus 4x plus 4 plus 9, or x squared minus 4x plus 13. This is a quadratic factor of our polynomial. So we're going to use this quadratic factor to figure out what the real root is, because we have two imaginary zeros. That means we'll have one real zero. This is a cubic, so it needs to have three roots. So I'm going to set up the long division here. So I'm going to put x squared minus 12x squared plus ax plus p, no missing terms, so I don't have to put any placeholders in. And I'm going to divide that by the quadratic factor we found, x squared minus 4x plus 13. When doing long division, the first thing we want to ask is how many times does x squared go into x cubed? And that goes in x times. So I'm going to write that over the linear term here. So now I'm going to multiply. So x times x squared is x cubed. X times minus 4x or negative 4x is minus 4x squared. And x times 13 is plus 13x. And the next thing we're going to do is subtract. So I'll put subtraction, put that in parentheses. X cubed minus x cubed is 0x cubed. Negative 12x squared minus negative 4x squared is going to be negative 8x squared. And ax minus 13x is going to be a minus 13, that quantity, times x. That'll bring down the p. We'll continue on with the long division. We want to know how many times does x squared go into negative 8x squared. That's negative 8 times, so I'll put minus 8. And then we'll multiply, and we get negative 8x squared. Negative 8 times negative 4 is positive 32, so this will be plus 32x. And then negative 8 times 13 is minus 104. And if we go ahead and subtract, we get negative 8x squared minus negative 8x squared is 0x squared. A minus 13x minus 32x is going to be a minus 45, that quantity, times x. And p minus negative 104 is going to be p plus 104. Here we're asked to find the real root. That comes from the quotient. So if we have a real root here, that means that x minus 8 has to be equal to 0, and so the real root is x equals 8. We're not asked in this problem, but if we were, we could find out what a and p are. So to figure out what a and p are, we would need this remainder would have to be 0. That means that a minus 45 would have to equal to 0, so a would be 45. And p plus 104 would have to be equal to 0, so p would be negative 104. So this is not asked, but we could find it. Oops.